Hello, today we'll shortly talk about morphisms from the spectrum of K to X, where K is a field and X is a locally ranked space. This is also an exercise in Hartshorne. And so let's start. I claim that it's equivalent to give a morphism from the spectrum of K. Again, K is a field to X, so X is a locally ranked space. You can also think of a scheme, and this morphism is, of course, a morphism of locally ranked spaces. Or instead of this morphism, we can give an element X in X together with a homomorphism of rings from the residue field at X into K, and the residue field is just given by the stalk modulo the maximal ideal. So that's clearly okay because we have a locally ringed spaces, and therefore the stalk is a local ring. So for the proof, we give two constructions that are inverse to each other, and once we've given them, it's easy to see that they are inverse to each other. Okay, we start with an observation. We take F from the spectrum of K, which is as a topological space, just a single point, but of course it is also a locally ringed space and not just a topological space. And then we look at the push forward of the structure sheaf or the direct image, which we'll see that this is the skyscraper sheaf at X. We'll see shortly what X is. Oops. And note that this notation is something completely different than this notation. So here once it's the residue field and once it's a skyscraper sheaf, but as I mentioned it, there should arise no confusion. And if you don't know or have forgotten what a skyscraper sheaf is, so if we plug in an open set hue, then we get K if X is in U, and 0 if it's not in U. Okay, so that's the first observation. Now let's assume we have our map of locally ranked spaces. So FFB from Spec K into X. And well, how do we get this point in X? There's basically only one choice. So again, we see it as a topological space as this one point space, and so by X, so X is the image. Okay, now we also have this map of sheaves, and so we could also, so we have two different ways to write it. And So that's just the skyscraper sheaf. And then we get an induced map on the stalks. So if we take this 1 point, then we get a map from OX, now f of this 1 point, which is x, into K, which is a local homomorphism. And now on the right hand side we have we have to have a single maximal ideal because it's a local ring, but the maximal ideal on the right hand side is actually 0, so you can check that the stalk there of the skyscraper sheaf at x is given just by K. And now, because this is a local homomorphism, the maximal ideal on the left hand side has to be the pre-image of the maximal ideal on the right hand side, so the pre-image of 0, and the pre-image of 0 is just a kernel. So that means that we get an induced map from OXX and modulo MX into K. So this is just the induced map from this map. Okay, so we have one construction, and now let's give the converse. Let's take an element in X and a homomorphism from K of X to K. And now again it's clear what the map should do on topological spaces, so it should just send this point to X. And now what do we do on sheaves? So we need a map into here, and again by the remark before, that's a skyscraper sheaf. And now we set this morphism of sheaves to be 0 if X is not in U. And what does it do if it's in U? Well, we first send X to S to this germ in the stalk, and then to the residue class modulo the maximal ideal, and then we apply phi. So Sx bar is the class of Sx in the stalk in K of X. And of course we have to check that this is a morphism of sheaves, and it's easy to check, but it's important to have this form here so that we have a skyscraper sheaf on the right hand side. So this is a morphism of sheaves because the right hand side is a skyscraper sheaf at X. Okay, and we have one more thing to check, namely that the induced map on the stalks is local. So our induced maps on the stalks are local, but actually we have just a single one because we just have the single point in the spectrum of K, and So one thing is clear, so we have this, so we look at the kernel of the induced map, and it's clear that the maximal ideal is in there because elements from the maximal ideal, so what we get is that S maps to Sx, and so basically, or rather we start with some Sx, and we map it to the residue class, and if it's already in the maximal ideal, then it's 0. And but now a homomorphism of fields is injective, and so we get that X is actually equal to the kernel of this map. So that's just because mx are the ones that get mapped to 0 under this map, and the map that comes afterwards. So afterwards we apply phi, but that's injective, so that's the kernel of the induced map, and therefore it's a local homomorphism, and that's what we needed. So we have to check it just on this single stalk, and we are done. Okay, thanks for watching. Have a good day. Bye.